Hello. In the final session of the Jointpoint regression, we are going to discuss the approaches for model selection. A main concern in regression model selection is how to select the best set of independent variables, and two major approaches of the model selection are hypothesis testing and information criteria approaches. The method for model selection in Jointpoint trend analysis software are permutation test, traditional BIC methods which include BIC, BIC3, and modified Bayesian information criterion, in short, MBIC. And we have data-driven methods which are weighted Bayesian information criterion and data-dependent selection. The permutation test compares permutations of the sampled observations and evaluates the likelihood of the observed sample. This is performed by sequentially applying the test of the null hypothesis that there are K0 joint points against the alternative hypothesis of K1 joint points. The procedure starts with K0 equaling JP mean, or the minimum number of joint points set by the user, and K1 equaling JP max, which is the maximum number of joint points set by the user. If the null hypothesis is rejected, permutation test will proceed to testing K0 plus 1 with K1 joint points. And if the null hypothesis is not rejected, permutation test will proceed to testing K0 with K1 minus 1 joint point. And the level of significance of the permutation test is adjusted to address this multiple testing. The BIC approach defined as the formula below, where the perm is the penalty term for the number of parameters of Jointpoint model. BIC should be used where the goal is to detect even slight changes. BIC performs better than other procedures when the effect size is small. However, it has been suggested that BIC has a tendency for overestimating the number of joint points when the effect size is relatively large. BIC3, which is defined by the penalty coefficient of 3k plus 2, imposes a harsher penalty on models with more parameters compared to BIC selection. In simulation, BIC3 performs better than BIC when the effect size is large. MBIC, which is defined in the formula, is the most conservative, with a tendency to choose a smaller model and works best when the effect size is very large. However, MBIC is generally not recommended for most users. WBIC is a data-driven method. Weighted BIC combines BIC and BIC3 using a penalty term based on data characteristics. The simplified formula for WBIC is, as you can see, BIC multiplied by 1 minus weight plus BIC3 multiplied by weight. The weight is estimated from the data for WBIC. When the effect size is large, more weight is given to BIC3, and when the effect size is small, more weight is given to BIC. In simulation, WBIC performs as well as BIC3 when BIC3 works better than BIC. And also WBIC improves BIC3 when BIC performs better than BIC3. Data-dependent selection is a method that is also data-driven. This method internally chooses between the model selection of BIC and BIC3 based on the data characteristics. Here are the references used for this presentation. In order to access model selection methods after setting up the data, we will come to Methods and Parameters tab, and here at the bottom all the model selection methods are gathered together. First we start with permutation test, which has two uh, settings that we can change. One is the overall significance level, which is set at 5%, and the number of permutations. It is not recommended to change the number of permutations if the user is not familiar with this procedure. Here we can choose other methods including WBIC, data dependent selection, or BIC, BIC3, and modified BIC. Here I'm going to start with permutation test and click execute. Here in the model selection tab, the test is shown. This test's null hypothesis, first null hypothesis was 0 join points against 1 because I had put the maximum number of join points at 1. And here the observed p-value is shown while the significance of the test is shown here. And for the female covariate I can show it here. It was 0.48, which is not significant. Therefore, the null hypothesis was not rejected, and the best model was 0 number of join points for females here. If we want to see all of the permutations test together, we come here and push view multiple models simultaneously and choose all models and come to model selection. Here, as you can see, the male and the female are shown together. As another example, this time I'm going to use WBIC. The inference method for data-driven BIC methods and traditional BIC methods is the same. After choosing WBIC and pressing execute, I will come to model selection tab, and as you can see all the models are shown here. The sum of squares is shown in this tab, and the corresponding BIC, BIC3, and the weight is shown next to the WBIC column. The method of inference is simple. Basically, regardless of the method you're using, the lowest value is the best model. For instance, for males, the model with 0 number of join points and 1 number of join points, when compared, it can be seen that the WBIC of the model with 1 join point is lower than the model without join points. And for females, the model with 0 number of join points has the lowest BIC value. So it's a better model compared to 1 number of join points. However, data-dependent selection method is a little different. So after choosing data-dependent selection, we will press execute. And when coming to model selection tab, you can see both values of BIC and BIC3. And in selection results, the results of data-dependent selection is shown, which is for males. The best model was BIC3, and for females, the best model was BIC. And if we come to these tabs, we can see the BIC values, BIC3 values. However, the rest of the inference is the same as explained previously. For instance, for males, BIC3 model was best, so the model with the lowest value of BIC3 is chosen. For females, the best model was BIC, so between BICs, the model with the lowest value was preferred, which is the zero number of join points.